Today, I would like to discuss 4 concepts that everyone should know to better understand how AI works. Those 4 concepts are big data, supervised learning, neural networks, and model evaluation. Let's get started with big data. Big data refers to the vast amount of information that exists on servers all around the world and is so large it would be impossible for humans to look through it all. Examples of big data include every photo you post on social media, every video you watch on YouTube, every song you stream on Spotify, and every search you make on Google. All of these actions create data, and when millions of people do these activities every day, it creates big data. Companies collect all of this information and use it to understand patterns and improve their services. Our next concept is supervised learning. Supervised learning can be compared to how I learned things as a young child. I was given flashcards to memorize and learn things like math, vocabulary, and images. After looking at several flashcards, I could identify things based on the patterns I had seen. This is similar to how supervised learning works as the AI begins to identify patterns as data is presented to it. Supervised learning includes 3 primary phases. The first phase is the training phase, where computers are given thousands of examples with the correct answers. Next, you have the learning phase. This is where the computer starts to identify the patterns in the provided examples. Then, in the testing phase, the computer is given new examples without answers to see if it can provide the correct output for the example given. A couple of real-world examples include voice recognition and medical diagnosis. With voice recognition, we feed the computer millions of recordings of people saying words, with labels showing what each word is. As the computer learns to recognize speech patterns, you get smartphones that understand when you say something like, "Hey Siri." With medical diagnosis, doctors provide the computer thousands of x-rays labeled with diagnoses, and the computer learns to spot the patterns, helping doctors identify problems faster. Next, we'll discuss neural networks. Neural networks are similar to the human brain, which consists of billions of tiny cells called neurons that work together to help us recognize things. Neural networks use layers to process information. For example, let's say we want to teach a neural network to recognize cats using 4 layers. We would feed pictures of cats into layer 1, or the input layer. Then layer 1 would break each photo down into tiny pieces. Then layer 2 would take over and look for simple shapes like circles and lines. Layer 3 would combine the shapes to find more complex features like ears and whiskers. And finally, layer 4 would put everything back together to decide if it was a cat or not. In this example, each layer passes its findings to the next layer. Neural networks are capable of finding incredibly complex patterns that humans might miss, and can be used in things like self-driving cars to recognize stop signs and pedestrians. Our final concept is model evaluation, which is the test that determines if the AI has learned correctly after the data is gathered, the learning process occurs, and the data is fed through the neural network. The AI system is given data it's never seen before to check and see if it truly learned the patterns or just memorized the examples. AI is evaluated based on accuracy, precision, and recall. Accuracy is how often the AI gets the answer right. If an AI correctly identifies cats in 95 out of 100 photos, it has a 95% accuracy rate. Precision is when the AI says something is true. How often is it actually true? If the AI says this is spam for 100 emails, and 90 of them really are spam, it has a 90% precision rate. Recall is how good the AI is at finding all the examples of something. If there are 100 spam emails in a folder, and the AI finds 85 of them, it has an 85% recall rate. Without model evaluation, we might think our AI is working great when it's actually making lots of mistakes. It's especially important to guarantee our AI is functioning correctly when dealing with medical AI and self-driving cars, as mistakes in these areas could potentially cost people their lives. Learning about these concepts was a real eye-opener for me, as it gave me insight into how I should interact with businesses in order to get the results that I want. A couple of examples are Netflix and Spotify, who both make recommendations for me based on the information they have collected from my viewing and listening habits. If I want to get better recommendations, I need to engage with the AI and review recommendations so they know how to refine their predictions for me. In conclusion, these four concepts work together to create the AI systems that we use every day, from music recommendations on our phones to the voice assistants that answer our questions. As technology continues to advance, understanding these fundamentals will help us navigate and succeed in an increasingly AI-powered world.